Greetings, scholars, and welcome back to another Algebra 2 video. I apologize for the echo. I'm recording in our classroom. This video will be on lesson 1.2, which is about key features of functions, but more specifically, it's really going to be about intercepts. You've had some exposure to this in Algebra 1, talking about the y-intercept, but in Algebra 2, we will also concern ourselves with the x-intercept. So first, a definition: an intercept is a place where a function crosses a specific axis. So note that when we talk about intercepts, we'll either be talking about the x-intercept or the y-intercept. So in order to kind of visualize this, let's go to a coordinate plane, and I'm actually using our class notes for tomorrow. So you will be receiving this in class when you come in. And the first thing is just, keeping in mind where the x and y axis are. So the y axis is the vertical, the x axis is the horizontal. And if you have a graph, it will be very easy, well, hopefully it will be very easy, I shouldn't make any assumptions, that you will be able to determine where those intercepts are. What may happen also is that it may be easy to spot them or point them out, but it may be tough to kind of designate what they are. So let's say we have this graph. So if I'm interested in my y-intercept, what I'm interested in is the exact place where my graph, which is this blue curve, is intersecting the y-axis. So that point would be right here. And that point is going to be, let's assume that these are all going up by ones. So that would make our y-intercept for this function 0, 4. Remember that when we are locating a point on the coordinate plane, that we look at the x-axis first. So this point 0, 4 is literally telling us, hey, to get to that point, we go horizontally 0, we don't move. And then we're going to go up 4 units. 1, 2, 3, 4. All right? So this 0, 4 is both the location of our point as well as the directions for how to get there. Right? A coordinate pair both acts as like an address and as directions to that address, which is pretty convenient if you think about it. Now, x-intercepts work the same way, except instead of being on the y-axis, they are on the x-axis. So my x-intercepts are going to be this and this, because those are the points where, and I'll just make a point here. You may not always see like a point like that, but if it goes through, or if it touches or starts or stops there, that's considered an intercept. And so my x-intercepts would be 1, 2, 3, 4, would be -4, 0, and 2, 0. So this is an x-intercept. This is an x-intercept. And then this is a y-intercept. So if you're looking at a graph, it's a very visual exercise. Just locate that point on the specific axis that you're looking for, and then write out the coordinates, and then you're done. What can be trickier is if you don't have a graph. So I'm going to use an example that is in your notes. So let's look to something like this. So we'll look at question 5. Now, if I have a graph and I look at all of the points on the y-axis, they all have something in common. And that is that every point on the y-axis has an x-coordinate of 0. If I was to try and get to a point that was on the y-axis, I wouldn't have to move to the right or to the left. I'm only moving up or down. So my x-coordinate everywhere on the y-axis is 0. By contrast, any point on the x-axis has a y-coordinate of 0. Now the reason for that is if I want to get to a point and that point is on the x-axis, I'm moving some distance left or right, but I'm not going up or down. Because if I did, I would be leaving the x-axis. So every point on the y-axis looks like this. And every point on the x-axis looks like this. So you'll have a 0 in the other coordinate. Now, the way that we make use of this information is if I want the y-intercept for this, so let's say I want the y-intercept for number 5, I know that on the y-axis, my x value is going to be 0. So what I do is I evaluate g of 0. I'm asking myself, hey self, what is y when x is 0? So we're going to evaluate this. 3 times 0 plus 11. Let me move this bar over here. I want to make this look a little bit clearer. Let's be clear that this is just one equation. So g of 0 is equal to 3 times 0 plus 11. 3 times 0 is 0. And that means that g of 0 is equal to 11. And that means that the point 0, 11 is on the graph. And because it has an x value of 0, that means this is our y-intercept. So this is our y-intercept. If I want the x-intercept, now I want the y value to be 0. Apologies. So now what I do is I'm asking myself, hey self, what value of x gives me a y value of 0? And now I solve this for x. So this is a little bit more involved because this involves us solving a linear equation. And so we get that x is equal to negative 11 over 3. And so our x-intercept is negative 11 over 3, comma 0. And that's it. So if you're looking at a graph, again, it'll be fairly easy to spot. You just want to make sure you're giving the coordinates correctly. If you're looking at an equation, you would literally plug in 0 for the other variable. So if I want the y-intercept, I plug in 0 for x. If I want the x-intercept, I plug in 0 for y. And that's basically it for lesson 1.2. We'll get some practice. Please let me know if you have questions. For this lesson, I do want you to include what's one question that somebody could ask about finding these intercepts. So I will be checking for this question as well, along with your notes. That's it for the video. Take care.